Okay, this is lesson 7.2, and in this lesson we're going to look at calculating surface area. We will calculate surface area of the various solids, and here are 4 examples that we're going to calculate surface area of. We need to be able to identify them, and to be able to identify them we need to be able to name them. So firstly, this shape here, we have a rectangle on top and bottom and sides. All sides are rectangles. This is called a rectangular prism. And the reason this is a rectangular prism is because we have a rectangle extended into 3D space and facing with another rectangle on the other side. So when you have a rectangle connected to a rectangle with a certain depth, you've created a rectangular prism. The next one is a triangular prism because we have a triangle face extended into 3D space connecting to another triangle. Triangle in the front, extended with a depth to another triangle. So triangle connecting to triangle, we have a triangular prism. Our next one, we have a square on the bottom, and this square is extended up into 3D space, but it connects to one single point. It doesn't connect to another square. If it connected to another square, it would be either a rectangular prism or a cube, if the side was a square. But since this connects to a single point, this is called a square-based pyramid. When we extend a face to a point, we create a pyramid. In our last one, we have a circle base extended into 3D space connecting to another circle. So you might think this is called a circular prism, and it is actually known by a more common name, a cylinder. But basically it's a circular prism. All right, so how do we calculate surface area? Well, surface area just means the area of all the surfaces. And when you have a complicated shape like a rectangular prism, there are a bunch of different surfaces, and one way to view them all is to break the shape down into a net. Starting with your 3D shape or your solid, you can unfold the solid to view all of its faces at once, and this is called a net. When we have a net, it will fold into the solid that it represents. The net form makes it easier to see all of the surfaces, and we can just calculate the area of each one, add them up, and that's how we find surface area. Another one is a cylinder. Imagine a cylindrical can. If you took the tops off, you'd have 2 circles, and if you peel the label around a water bottle or around a pop can, you'd see that that label is a rectangle. So to find the surface area of a cylinder, we're looking for the area of a rectangle plus 2 circles. So basically, the surface area of a solid is just the total area of all the surfaces of its net. So if we break the shape down into a net, we're just looking for the area of all of those faces. So let's see if we can match some nets to some solids. Our first one, we have 1, 2, 3, 4, 5, 6 square faces, and we have the solid options right here. The only one with 6 square faces is A, so this first one is net A. Our next one, we have a square and 4 triangles. That kind of looks like this one, but this is a square with 1, 2, 3, 4, 5, 6, 7, 8 triangles, so it's definitely not this one. But if we look at F, we have a square base with 1, 2, 3, 4 triangles. So our second one is F. C, we have 3 rectangles and 2 triangles. That would be shape H. 2 triangles on the end and 1, 2, 3 rectangles. Left side, right side, and bottom. This one's a little tricky. We have 1, 2, 3, 4 triangles. And if we look, this one just has rectangles, this one is, or squares, this one's squares and rectangles, this one's got triangles, 1, 2, 3, and then 4 on the bottom. So it's definitely going to be C. If we look at E, E again is pretty tricky. We got 1, 2, 3, 4, 5, 6, 7, 8 triangles. When I was counting this one, I got 8 triangles, but I also got a rectangle in the middle. But the thing about the rectangle in the middle is that it's not actually on the outside of the shape, so it doesn't count as one of the faces. So this shape really is just 8 triangles. So that's D. And our last one, we've got 1, 2, 3, 4 rectangles and 2 that might be squares or rectangles, can't really tell. That would be B. We've got 1, 2, 3, 4 rectangles and 2 rectangles on the end to give us 6. So that's what we need to be able to do. We need to be able to match the net to the solid or take a solid and break it down into its net. So let's look at an example. Drawing a net and calculating surface area. Well, let's look at our first shape. We have a square base pyramid. So if we were to break this down into a net, what would this look like? Well, we have a square, so I'm going to draw a square. And then off of the square, we have 1, 2, 3, 4 triangles off of each side. So 1 triangle, 2 triangles, 3 triangles, 4 triangles. And all these triangles are the same. So we got shape 1, or shape A, which is a square, and shape B, we've got triangles. So shape A is square, and shape B is a triangle. Well, how do you find the area of a square or a rectangle? It's just length times width. And for a triangle, it's base times height divided by 2. And if you don't remember that, at the end of the lessons package, the end of the unit, if we flip forward a few pages, we have this page, measurement and formula sheet. And if we go look, here's our square base pyramid. So all the calculations or all the equations you would need are right there. Okay, so let's flip back. All right, so we've got the area of the square, area of the triangle, and there's only one square, but there are 4 triangles. So let's see if we can find some areas. Let's start with the square. Length times width. Well, if we look at the shape, our square shape is 12 by 12. So we've got 12 times 12, which is 144. And we're working in feet, so we got square feet. Remember, for area, the units are always squared. For area B, we're working with the triangle. Now the triangle's a little tricky because if we steal the measurements from the triangle that we're given, we know the bottom is 12 and we know the side is 36. But we don't know the height of the triangle, which is important because we need the height of the triangle. The height of the triangle is not this side. We need this. We have the base is 12, but we need the height. How do we find that? Well, we use one of the triangles as a right angle triangle and we solve for the height. Half of the base would be 6, so we have 6 and 36 and we want to find the height. How do we do that? We use Pythagorean theorem. A squared plus b squared equals c squared. C squared is the long side, 36. A squared is our height, and b squared is half of the base 6. So now if we do a little bit of math, height squared is plus 36, because 6 squared is 36. 36 squared is 1296. Solve for h squared. We move the 36 to the other side. And our last step is to square root. and we end up with a height of 35.5. Now that we have the height, we can find the area of shape B. The base is 12, the height is 35.5, and we're going to divide by 2. So if we get our calculator, we've got 12 times 35.5 divided by 2, which is 213, and it's square feet. So now we know the area of the square and the area of the triangle. So if we want the total surface area, what do we have to do? Well, we have to add them up. We've got 1 of area A plus 4 of area B, because we have 4 triangles. So that means we have 144 plus 4 times 213. And if we do that math, we end up with 996 square feet. Alrighty, we're going to do a couple more examples. Next shape we have is a rectangular prism. And if we look, we have 3 measurements, 10, 4, and 5. So every vertical edge is going to be 4. Every diagonal edge is going to be 5. And every horizontal edge is going to be 10. So I'm going to do a little tick. Tick, 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 to show they're all 10. And for 4, I'm going to do double ticks to show they're all 4. And for my diagonals, I'll do triple. There we go. So if we break this down into a net, we've got 4 rectangles through the middle and 2 rectangles on the end. So we end up with something that looks like this. We've got our top and our bottom rectangle. We're going to call that rectangle A. We've got our front and back rectangles. We're going to call them B. And we got our side rectangles. We're going to call them C's. The top rectangles are 10 by 5. So we've got 10 by 5. And our front and back rectangles are 10 by 4. And our side rectangles are 4 by 5. And there we can kind of see all the measurements on our rectangles. So area A we called top and bottom. Area B we called front and back. And area C we called sides. So top and bottom. Top and bottom are 10 by 5. So we've got length times width, which is 10 by 5, which is 50. Front and back, we got 10 by 4, so that's length times width, 10 by 4, which is 40. And sides, we got 5 by 4, so length times width, 5 times 4, 20. How many of each do we have? Well, we've got 2 A's, 2 B's, and 2 C's. So we've got 2A plus 2B plus 2C. So we've got 2 50s plus 2 40s plus 2 20s. which would be 100 plus 80 plus 40, which is 220, and we're working in centimeters, so it's centimeters squared. And there we have it. Okay, let's try number 2. We have here a triangular prism. And if we break this down into a net, we'll see we have a shape on the bottom, which is a rectangle. And off of that rectangle, we have 2 triangles that are right angles. On the back, we have another rectangle. And on the front, we have a big rectangle. And there's our net. Let's see if we can put some measurements on here. This slant right here is 8. So we have 8. And that makes this one 8 as well. The front edge is 7, which makes all these front edges 7. And 6 is our bottom edge. Which means this is also 6. So we're missing a measurement. Oh, I missed 8, 8. We're missing a measurement. We're missing right here and right here. That's our slant side, C. And we can find it using Pythagorean theorem. C squared would be A squared plus B squared. And if we look at our triangle, we got 6 and 8. 6 squared plus 8 squared is 36 plus 64, which is 100. And if we square root 100, we get 10. So C is 10. And now we have all of our shapes. So we can pick which one we want to name which. Let's call this one A, this one B, this one C, and these 2 triangles are the same, so we'll call them D. So shape A is a rectangle, 10 by 7. So its area is 70. Shape B is also a rectangle, 8 by 7, which is 56. Shape C is a rectangle, 7 by 6, which is 42. And shape D is a triangle, but there's 2 of them. Our triangle would be base times height divided by 2. The base is 6, the height is 8. The base and height are always around the right angle. So 6 times 8 divided by 2. 6 times 8 is 48, divided by 2 is 24. So if we want to find the total surface area, we have to take A, add B, add C, and add 2 D's, because there's 2 triangles. So we've got 70 plus 56 plus 42 plus 2 24s. If we add all those up, we end up with 216 centimeters squared. Now, if you don't like breaking it down into nets, what you can do is you can go to your formula sheet, identify the shape that you have, and then just use the equation that's given in the question. Match up the letters. So if we wanted the surface area of our rectangular prism, instead of drawing the net, we can just do 2 times length times width. And length would be this edge, width would be this edge, plus 2 times length times height, length and height, 2 times width height, width and height, and just match up the sides to the measurements. You can do the same with your triangular prism. You can do the same with your square-based pyramid. All the shapes, surface area equations are written right here. Just take the part where it says SA equals and use that equation. You can use the or if you'd prefer, and any notes that are included in there are also helpful. Like if you need to remember what the area of a triangle is, it's base times height divided by 2. And so on and so forth for all the shapes that we would need surface area of. So what I'm going to ask you to do now is take a look at the last one and see if you can break it down into its net and find the surface area. The answer is posted on the course website, and give that one a shot. And that's it for lesson 7.2. Thanks for watching, and I'll see you in lesson 7.3.